Thank you for inviting me to International Day of Women in Statistics and Data Science. In this talk, I will talk about algorithm for clustering COVID-19 data with an overview of current trends and visual approaches. What is COVID-19? Coronaviruses are a large family of viruses, and COVID-19 is an infectious disease. The first case was reported on November 2019. The symptoms of severe COVID-19 include shortness of breath, confusion, persistent pain, or pressure in the chest, which can develop into respiratory failure. Here is the history of COVID-19. On the last day of 2019, the first clusters of pneumonia-like illness were reported in China. And on January 13, 2020, WHO declared a public health emergency of international concern and designated COVID-19 as a pandemic on March 11th. Since then, our daily lives have destroyed. Many cities were locked down, people had to stay at home or had to wear masks everywhere. Many schools taught online classes and meetings through Zoom became a daily routine. I think many people here have experienced it. At the end of 2020, FDA authorized the first COVID-19 vaccines. After that, many people were vaccinated and our lives began to return to normal. A lot of variants have occurred, from Alpha to Omicron. These are the most popular variants: Alpha, Beta, Gamma, Delta, and Omicron. Most viruses evolve in the direction of decreasing pathogenicity and increasing propagation power. Omicron, which is now a major species, has exploded the number of infectious diseases since November 2021, but most patients showed weak symptoms, which allows us to return to our daily lives. There are two sources of COVID-19 data. One is from WHO and the other is from the Our World in Data site. The WHO provides daily data on the number of cases and deaths and weekly data on vaccine. Our World in Data provides COVID data with other interesting variables, including population, GDP, life expectancy, mortality, and etc. In this research, we use data from Our World in Data between January 2020 and June 2022. First, we explore the overall profile of newly reported COVID-19 cases and deaths. The original data is daily data, but we had converted that into weekly data. The x-axis represents the date and y-axis represents the new cases and new deaths per week. The blue line shows the case and this red line shows the deaths worldwide. We can see the alpha, beta, gamma, and delta and Omicron effect. In this plot with death, the patterns are quite different. A peak is at the beginning of 2021, and since then, the deaths are gradually decreasing. Of course, there are a couple of peaks in the beginning of COVID-19 and here and here, and here due to Omicron, which also shows a high peak in the new cases. To compare each country's profile and overall profile, we draw the following picture. After calculating the cases and deaths for each week per country, we rescale them to 0 for minimum and 1 for maximum in each country. The light gray line shows the profile of one country. Most countries shows the peaks in Omicron, but some countries has a peak in the other period. But now most countries are generally moving away from the Omicron with an overall decline number of cases. In this plot with deaths, patterns are quite different. Peaks are spread all over the place. Some countries have a high peak at the beginning of COVID-19 and the others are here, here, and here. After the beginning of 2022, the new deaths are gradually decreasing in most countries. To see the seriousness of COVID-19, we calculate the death rate as number of new deaths divided by the number of new cases in each week. This number is not accurate because there is a time delay between case and death. However, here we calculate this rate without considering the time delay because it's just for exploring the approximate severity. This red line is the overall death rate, and this gray line shows the death rate of each country. As you can see, the death rate was very high at the beginning of COVID-19, but it has decreased. In particular, since 2022, the number of new cases has increased significantly due to Omicron, but the death rate has constantly been declined in most countries. To explore the case and death with the percentage of vaccinated people, we draw this plot. This is for South Korea, and blue line shows the cases and red line shows the death. The gray line here shows the profile of the other countries. The green background shows the percentage of vaccinated person. In Korea, vaccination began in April 2021. Now, more than 80% of people have been vaccinated. We can see a high peak in this Omicron and another small peak in Delta and Alpha. The United States. This is the plot for the United States. And United States shows a peak in the case in Omicron and a couple of peak of deaths at the beginning of COVID-19 and Alpha, Delta, and Omicron. This is the case versus death rate. A peak in death rate in Korea is at the beginning of COVID-19. For the United States, highest peak at the beginning of COVID-19 and few small peaks in here and here. We explore several profiles: the number of cases, death rate, and percentage of total vaccinated. To compare all these profiles simultaneously, we change profiles into distance image. This lower triangular shows the profile of new cases, and this upper triangular shows the profile of new deaths for Korea. In the right plot, the lower triangular shows the percentage of total vaccinated, and the upper triangular shows the reproduction rate. In each part, the values are rescaled. White represent the minimum and dark blue represent the maximum. This is for the South Korea, and case and death shows the highest peak in March 2022, and the death shows a small peak at the beginning of 2021 and 2022. Total vaccinated started in March 2021 and continued to increase until for 2021 and reaching almost the maximum value. In the United States, that's Mumbai and that's the United States. Okay, in the United States, high peak in cases here and small peaks here, and couple of peaks in death here and here. Yeah. This is the animation plot of total cases and total deaths in each country. At the beginning of COVID-19, the number of deaths is rapidly increased compared to the number of cases. As the Omicron spread since November 2021, the number of cases growing rapidly, but the number of deaths is gradually increasing. So we can see this one. In this talk, we focus on time series clustering in R. Many packages are already being developed. TS-clust and TS-dist are for calculating distance of time series data, and this one provides representation of time series data like dimension reduction and normalization. And FIST and TS features are for feature extraction, and BNP TS-clust for the Bayesian nonparametric algorithm for time series clustering, and PDC is for the permutation distribution, and DTW-clust used dynamic time wrapping distance for clustering. This one is also for the dynamic time wrapping distance, and FABLE is a collection of time series forecasting models, and T-SIBLE is tools to manipulate and analyze temporal data. And there are many packages for general clustering in R, and this one, and clust, NB-clust, cluster sim, F-clust, and vector cluster, etc. In the clustering with time series profile, we use the top 30 countries with large population and the data between January 2020 and June 2022. We use 21 measures like this and tried 8 different methods in H-cluster function. We use a couple of R packages, TSDS package for distance calculation, H-cluster function for clustering, and NB-cluster for finding the optimal number of clusters, and cluster crit package for calculating internal validation measures to evaluate the clustering method. First, we use the time series profile of cases and calculate Euclidean distance and use complete linkage in H-cluster. This results from clustering using the whole time series between January 2020 and June 2022. The best number of cluster is calculated using NB-cluster function. We have 5 clusters. Cluster 1 has 1 peak in Omicron, and the other peaks are spread over the rest of the period. Cluster 2 has a peak only in Omicron, and cases show subtle ups and downs in this period. And this Egypt is an exception. Cluster 3 has a mixed one, different peaks in Omicron, in this Omicron period, and some fluctuation a bit more than the cluster 2. Cluster 4 shows a wider peak in Omicron. Duration of Omicron is relatively longer than the other clusters. And cluster 5 is South Africa, and this one shows the quite different patterns, peaks in every summer and winter. Because almost all countries show an extremely high peak in Omicron, it is not easy to see the patterns in 2020 and 2021. So we divide the whole range into 2020 and 2021 and 2022. This is a result of 2020, but before clustering, we rescale the profile from 0 to 1 in this time period for each cluster and for each country. The cluster 1 shows an increasing pattern of peaks in late summer and after decreasing a bit and increase again. Cluster 2 shows quite different patterns. Tanzania have peak in April, and China has a peak in February, and Vietnam has a peak in August. except for a peak, almost no cases in the other period. And cluster 3 shows 2 wide peaks, one in early summer and the other in late winter. Cluster 4 shows a rising patterns, peaks after fall. And cluster 5 shows a wider peak in August and September. And cluster 6 shows a rising pattern, peak in December. As you can see, the characteristics of each country are clear. And this is a result of 2021 after rescaling in 2021. Cluster 1 shows the peaks in late summer and late spring. Cluster 2 shows large cases until June. After that, Brazil shows decreasing patterns, and Egypt shows ups, downs, and up patterns. And cluster 3 shows high peak in December and another fluctuation in other period. And cluster 4 shows wide peak between June and August and between October and December. Because Omicron starts in November 2021, we tried clustering with the profile between November 2021 and June 2022 after rescaling. Each cluster shows a similar period of prevalence of Omicron. Cluster 1 shows a peak in January. After that, there are subtle ups and downs in this period. And cluster 2 shows a peak in March and April. And cluster 3 shows a peak in December and January and small peaks after April. And cluster 4 shows a wide peak between February and May. It means Omicron have been prevalent for a long time. Cluster 5 shows a peak in February. As we saw, clustering with subsequence shows quite clear characteristic. However, the clustering with the whole time series does not have a clear explanation. That means the result of clustering is not good. So we tried a different approach, use image instead of time series profile. So we convert this time series to this image. To compare the result of clustering with time series profile and result from the image, we use 21 distance measure, 8 clustering method, and 23 internal validation measures in cluster crit package. After that, we explored the result of clustering with random forest and PP3Bs. Each distance and each clustering method are applied to the time series profile data and find the optimal number of clusters using the MB cluster function. After that, the same methods with the optimal number of clusters are applied to the image data. And then 23 internal validation measures are applied to each clustering result. And we calculate the differences to find out which clustering was better. The proportion of how many of the 23 internal validation measures are better for clustering using the image data than using the time series profile was used as the criterion for judgment. This is a result. That's a histogram of proportion. In most cases, proportion are over 50%. This is a plot of optimal number of clusters versus proportion. Most lousy dots are over 75%. This means clustering with the image is much better than clustering with time series profile. To compare the exploratory power of the cluster, we choose one clustering method, wild.t2 with Manhattan distance. Optimal number of clusters is 4. The left two column shows the result with the time series profile, and the right two column shows the result with the image. This profile shows a bit clear pattern than this one. The left panel shows the result from the time series profile. Cluster 1 shows one Omicron peak and a couple of peaks in the other period. And cluster 2 shows one wider peak in Omicron and almost nothing in the other period. And Thailand is exception. And cluster 3 shows peak every summer and winter, and cluster 4 shows one wider peak in Omicron and subtle ups and downs in the other period. Right, this right shows the result from image. And cluster 1 shows two peaks, one in Delta and the other one in Omicron. And peaks in Delta is bigger than the peaks in Omicron. And cluster 2 shows one big peak in Omicron and subtle ups and downs in the other period. And cluster 3 has the same as cluster 2 in the result of time series profile. And cluster 4 shows a sharp peak in Omicron, and location of this peak is earlier than the other cluster. Also, a couple of peaks in summer and winter. As you can see, the cluster's characteristics are much clearer on this side. To look at the cluster's feature more closely, we fit random forest with the clustering result as class information. This is the importance measure of each variable. This upper panel shows the result of the image, and this lower panel shows the result of the time series profile. In this plot, variable means weeks between May 2020 and June 2022. In this time series profile, high importance measure were November 2020, but in image, high importance measures are November 2020 and summer 2021 and the beginning of 2022. So the result of the image is more reasonable. However, the fitting of random forests are not perfect. For cluster 3, in time series profile and cluster 1, in the image, random forest could not detect the exact clusters. So in this importance measure, the effect of cluster 3 or cluster 1 may be omitted. So we tried the projection pursuit classification tree. The projection pursuit classification tree used the projection pursuit approach and projection pursuit indices for classification. Depth of tree is at most g-1, and each node separate classes into two groups instead of data. In each split rule, we can figure out which variables are important to separate two groups using projection coefficient. PP forest extend the PP tree to the forest. If you want to learn more about the PP tree and PP forest, these are the list of reference. And this is the result of PP tree when we use the clustering result of time series profile as a class information, and this is for the image. And fitted trees are different. According to the confusion matrix, these trees are perfectly fit. So we can see the effect of all clusters. The left panel shows the profile of each cluster, and right panel is the result of the PP tree node width function. It's for exploring each node in PP tree. First, we explore the node 1. In PP tree with the image result, cluster 3 is separated from the others. cluster 3 is separated from the others. So this is the plot of projection coefficient in node 1. And this is a histogram of projected data onto this projection. From the coefficient plot, we can see that the spring 2022 shows negative effect, and for 2020 shows a positive effect. Also, we can see this peak in September 2021, this one. And this plot shows the mean of each variable in the left and right node. In here, left node is cluster 3, so this is the mean of cluster 3. Red line shows the significantly higher or lower mean than the other side. And cluster 3 has a lower mean in the summer 2020, and the high value in the spring 2022. In node 3, cluster 4 is separated from the others. In the profile plot, cluster 4 shows a sharp peak in Omicron and few wider fluctuation in the rest of the period. The sharp peak drops rapidly and continues with very small cases for a while and then starts to increase. From the coefficient plot, we can see a couple of positive and negative effects because cluster 4 has complicated positive and negative effect because cluster 4 has complicated characteristic. And node 4 split the cluster 1 and 2, and in the profile plot, cluster 1 shows high peak in delta and small peak in Omicron and subtle ups and downs in the other period. Cluster 2 shows a high peak in Omicron, a big fluctuation in the other period. According to the coefficient plot, summer 2021 and April 2022 shows a negative effect, and May 2020 and October 2020 and March 2022 shows positive effect. Left node shows the cluster 1, this one, has high value in summer 2021 and lower in January 2022, and cluster 2 has a positive direction. As we see, the cluster result from image show more clear patterns. Another advantage of clustering with image is that we can add depth information for clustering in this way. The lower triangular shows the cases and upper triangular shows the depth. So in this talk, we talk about clustering with time series profile. We can use time series only method and use general clustering method with special time series representation or distance measure. We tried to use image data for clustering. In the image data, time dependency is included and able to add another information like we add depth image in upper triangular. So in this talk, we just use H-class method, but we can apply deep learning algorithm for clustering. I'm an R person, not Python person, so I stick with R in this presentation, but in some time, sooner or later, I'll try to deep learning in R. Okay, we also explore the clustering result with classification method, use random forest and PP trees. And these are the references. And this is our team with PhD students and master students. So if you have any question, and send me an email, and this is my email address.